So whenever we say inertia, it is something related to mass, correct? So whether the object is at rest or the object is in motion, inertia is related to it, correct? And you guys saw the examples of inertia also. So now what I'll do is, so let's say I have two objects, one is of lighter mass and one is of heavier mass. Okay. Now both of them I'll drop from the top of a building. Okay, let's say 2 or 3 story building, I'll drop both of them from the top of the building. Now let's say you have to catch them. Now the easier one to catch and the harder one to catch. The easier one is the lightweight one and the harder one would be the heavier one, correct? Right. So why do you think it's harder to catch the heavier one? One is, when you catch it, it hurts your hand, obviously, because it's heavy. Right? Imagine a stone, a heavy stone and a light stone. So the heavier stone will hurt your hand. So meaning, the force with which it's actually hitting your hand, it depends on the mass, because the lighter stone is easier for you to catch, whereas the heavier ones, that is much harder than this. Correct? So I can say that force is depending on the mass here, or whatever the force, whatever you are calculating. Correct? Right? Next is, suppose let's say it's not only mass it's dependent on, it's also dependent on the velocity. See, for example, let's take an example of a bullet. See, how big is a bullet? Bullet is like so much, that's all. It's very small, correct? Whereas, if I'm actually shooting at something, imagine the velocity of the bullet, it goes at tremendous speed. Now, if you are actually close enough, then it can cause a lot of damage to you, correct? So, if somebody is shooting something and if the object is very close, then the bullet will cause very high damage to it. It's a big damage. So, in this case, suppose let's say I'll decrease the speed of the bullet. Let's say I'm only throwing the bullet, like how I throw the stone. See here, it's not going to make much of a difference, correct? It's like it won't even hurt you, actually speaking. It's like small thing which is coming and hitting you, nothing else. So in this case, what did you notice? See, the mass is the same, but what is happening to the velocity? Velocity increases, then the impact, what it does, that also increases. Whereas in the previous example, the stone example, so there mass was increasing, the impact again was increasing, correct? Because heavier stone, the impact on your hand is much higher than the smaller stone. So, if you look at these two, so what we come across is you come across another important concept in physics. We call it as linear momentum of an object. Okay? So linear momentum. Now I'll give you one more example. Let's say you are playing cricket. Let's say somebody hits a ball and you have to catch it. See, nobody will catch like this. What we do, we take the hand towards ourselves so that the ball, the force whatever is acting on your hand, that comes down. Okay, it won't just hit your hand and the ball won't jump. So what happens? You take the ball towards each other, towards you, correct? See, in this case, what you have to notice is, it's not just about force which is acting on the body, right? It's also about how much of time duration you're giving for the body to act on you. For example, cricket ball. So, if you take the cricket ball, see, if I try to catch it like this, there is a huge chance that the ball will come here and it will just drop off, correct? Whereas, if I just do it like this, now what happens? I'm giving enough time for the ball to release the energy, correct? So, time also comes into picture. So, what did you guys learn now? So, you learned about how mass is important, how velocity is important, and how the time you're giving for the body to relax, that is also important, correct? You guys understood the difference between these three examples. First is mass, second was velocity, third was the time, correct? Now, when it comes to linear momentum of an object, now momentum, we define as the product of mass and velocity. Okay, for example, bullet, very small mass but very high velocity. So your momentum is high. Okay, whereas take an example, let's say I have a huge loaded truck. Okay, a huge loaded truck. Like let's say the mass of the truck is somewhere around 200 tons. Okay, now even if a truck which is weighing 200 tons is going at a speed of let's say about 20 kilometer per hour, the momentum is very high, don't you think? Correct? Because see, let's say you have a huge loaded truck and a car. Okay, the huge loaded truck can see it can just go through a wall also, correct? Because it has very high momentum. So momentum we define it as product of mass and velocity. Understood what is linear momentum? So this linear momentum is actually a vector quantity because see linear momentum P is equal to m into V. V is a vector, so P becomes a vector. So your linear momentum has both magnitude and direction. Okay, so coming to the SI unit, see basically it's mass and velocity, correct? So mass is kg, velocity is meter per second. So the SI unit for momentum or linear momentum becomes kg meter per second. Okay, kg meter per second, and the dimension formula becomes m l t minus 1. Okay, so understand what is linear momentum. In the next video you'll see few more examples of linear momentum so that you guys can understand it better. Understood?